so nice to be in a room with real people. And thank you for how many it is on Zoom. It's nice to have you with us. This is rather a special day because we knew that this meeting would be a combination. It's a joint meeting between the Cirencester Archaeological and Historical Society and also the Cirencester Science and Technology Society. So we needed a subject which was scientific, but also obviously very historic and would interest lots of people. Now, I knew that in 2013, two lads, so this was Christian Thompson and Robbie Cridley, they found the skull in the River Coln at Fairford. And I believe, Christian, that you're on Zoom somewhere, but you didn't want to get involved. Hello, Christian. It must have been a pretty scary moment finding a skull. I mean, we kind of look at it now because we know that it's old, but you didn't know it was old, did you? It's a real Stephen King moment, wasn't it? Horror to see that skull looking up at you. And what your family have told me is you did exactly the right thing. You ran to the family to tell them that you found a skull in the river. And they were distracted at the time. I believe they were watching Andy Murray play tennis. So didn't take in what you said. When they came back to the spot with you, they realised that it was real. And that's when they called in the Gloucester Police. And we have Eleanor here from the Gloucester Police who went to the scene. And you, at that time, you didn't know whether this was a modern murder or...
No, at the time, no.
And then,
there was a skull going. What happened in our apartment? We told us it's a skull and it's definitely human. What happened? It isn't. So the first step is to go and retrieve it, and then I said to me, yeah, okay, maybe a bit more to this.
And then I believe you took it to your forensic anthropologist, who is Lisa Donnell.
Yes.
And Lisa Donnell, she looked at it, examined it, and I'm not an anthropologist, but when she was holding the skull, and I think, Lisa, you might be online as well. Lisa, it moved, didn't it? And apparently a crayfish, is that right?
Yeah.
Crawled out of the skull. And so you had your Stephen King moment, Christian. Lisa and Eleanor, they had their Hammer horror moment. So it wasn't actually moving. So. And then from there, the samples were sent over to Cellmark, which was where Linda's company came into the scene. And meanwhile, this went out on the national press because Lisa felt that this might be a woman of African origin. And I believe I've got Sid Flatman in the audience here somewhere. If I could Sid, I asked you what was the state of Fairford at the time when the skull would have been there, because thanks to Cellmark, you now
You're just stealing my thunder here. You do realise this.
Yeah.
It
was a big town, wasn't it, Fairford? There were a lot of people there.
In that area, yeah. Well, in 1086, the Domesday Book records 3 mills in Fairford. Well, I've identified where those 3 mills are, and one of those mills is only a few yards away from where that skull. Well, I thought there was a whole skeleton found. Right. Was it just a skull?
Thanks, Sid. So thank you very much.
So there was a lot of activity in that area at the time.
So I'm getting told off by Linda because I know she's got a huge talk to do.
No, it's just you've just stealing my thunder.
Well, I'm so pleased to have such a knowledgeable audience here today and online, and very pleased to have you, Linda, because you've had to come all the way down from Chorley, so that's no mean distance. Linda, you are a chartered forensic anthropologist. You are the senior forensic reporting scientist, lead forensic anthropologist at Cellmark. You worked for, well, you joined Cellmark in 2012, didn't you?
That's right.
And before that, you were 14 plus years with the Greater Manchester Police as a crime scene investigator. And before that, you were with the Leverhulme Trust Research in Forensic Anthropology. And we're very lucky to have you here tonight. So I've taken up enough of your time, Linda. Thank you very much.
Thanks ever so much. And yeah, welcome everyone. This is a fantastic opportunity and very different from when I often stand in front of people, which is in court. So I'm hoping it's not going to be quite such a grilling, but please grill away. You've already heard from Barbara, the number of people involved in this. And I do want to say that, in fact, even though I'm stood here, my part was actually very small. But I think Barbara was also interested in what forensic anthropology is. So I'm going to do a little bit about that as well. But yes, very, very much a team effort from discovery all the way through to where we are now and the museum. And I'll touch on that and people. So I will be pointing and asking other people to contribute with their particular knowledge about this case. So I'm not quite sure how many of you are aware of forensic anthropology and exactly what it is, but I just thought I'd sort of start with that. But I think more importantly is, unsurprisingly, tonight we are going to see pictures of human remains, but I've been dealing with human remains all my career, from my undergraduate as in anatomy, and I think we really need to take a moment to pause about what that means to be, seeing and dealing with human remains. So I don't do it lightly, and I'm sure everyone who deals with human remains feels the same. For me, I remember being outside the lecture theatre, the dissecting room, on my first day, and being told what a privilege it was to work with human remains, and that carries through all the way through today, and overriding in all work in osteoarchaeology and forensic anthropology is the fact that we need to treat human remains with dignity and respect. These were people, so showing human remains needs some consideration, and one of them is the situation appropriate? And this is a learned society, or I believe 2 learned societies, and there is an educational push here. So that I feel is appropriate. And also, certainly in my forensic work, we always have to be aware of individual variables about this certain case. Who might that affect? Living relatives. What are the conditions of the remains? Is it appropriate to show human remains in different states and things like that? And obviously, all through history, remains could have died in various different ways. So hopefully that sets the tone for looking at human remains, and I feel with this audience that everyone is on the same page with that. Okay, so there's various experts who work with human remains, and osteology is the general term, but you have biological anthropology, physical anthropology, and forensic anthropology. And basically, as you'll see with the crossover of the work that's been done both by myself and Victoria, who will introduce properly in a wee while, the analyses are very, very similar. But specifically, forensic anthropology is the analysis of human remains for medico-legal purposes to assist the courts. So that's it. A lot of the time it's the same work, but we have an eye on the fact that we're within the judicial system. So training generally is in skeletal anatomy, and we need to understand human variation, and basically anything that can affect bones through life and what leaves marks on bones. And also after death, so everything through traumatic injuries and diseases on bones, but also after death, what happens through decomposition, factors like animals, and anything from sort of burial environments through to fire, disruption and things like that. So anything that affects bone, really. The landscape of forensic anthropology has changed quite dramatically over the last 10 years. And I put this in a context because, again, it just sort of, it shows this sort of seriousness and rigor that has come into the field in the last sort of 10 years. There's a government post called the Forensic Regulator, which I'm sure our forensic colleagues will know very well. This is a government appointed position to ensure that any forensic science is done to high scientific standards. And there's a code of practice now on its 7th issue. And last year, the Forensic Regulator was granted statutory powers. So this is serious now. Through sort of miscarriages of justice and things like that, this is seen to be essential within the criminal justice system. So basically, it means that the regulator oversees quality and ensures that anyone undertaking forensic science works to the codes of practice to ensure that there isn't any adverse effect on criminal investigation, prejudicing cases and things like that. So this weighs quite heavily on forensic sciences, everybody in the criminal justice system. But what's happened in forensic anthropology in the last 10 years is that we have to demonstrate that we are maintaining professional expertise. So we have to be current, we have to be practicing. And part of that is to show that we are competent, and we are assessed as competent by, in our case, particularly our peers, but via certification and for myself, chartered status through the Royal Anthropological Institute. And that involves going through examinations and keeping a portfolio and things like that. So a lot more rigor has come into forensic anthropology, and quite rightly. So it's not just yourself as a person, but also the techniques that you're using. So we have to ensure that the techniques are appropriate, usually in our case, scientifically validated through peer-reviewed journal and research. But also our own personal work has to be peer-reviewed. So everything I do needs to go to another anthropologist to be checked. And ultimately, although we are instructed by the police, our overriding duty is to the court and the criminal justice system. So as a forensic anthropologist, as opposed to an osteologist maybe, we have to understand the obligations to the court of being an expert witness and all the police processes of sort of disclosure and things like that. So it has changed the landscape, but ultimately, as you'll see, the methods are very similar, whether we're analysing a skeleton from 2 or 3 years ago to one that is hundreds, thousands, and even having come from a background in human evolutionary anatomy, millions of years. Okay, so what does forensic anthropology cover? Well, a lot of the time the police will ask, is this bone human? So that's one of our basic and very common exams. So we have to be able to recognise what is human bone and what's non-human bone, even when it's fragmented and changed. Once we've established whether it's human, the next question tends to be, how old is it? Is it of police interest? So we have to understand how to do that, and that's quite a part of what we're going to talk about tonight. So the date of death, post-mortem interval, the time since death. We do scene work, so we will go to scenes and do interpretation of the remains in situ. And one of the key things, obviously, once we know they're human and they could be recent, is who is this person? Because the police can't start a death investigation or a murder investigation without, usually without knowing who that person is. So the skills of being able to estimate age and sex of the individual, stature, and ancestry, their biological heritage. More so, I think, in forensic anthropology than other skeletal analysis, we are looking around the circumstances of death, and that can be anything from non-suspicious all the way through to quite obvious and brutal murder. So understanding traumatic injury is throughout all skeletal analysis, but that tends to be the thing that gets you into court at the end of the day. So as forensic anthropologists, these are sort of things that we get involved with. As I say, incidental finds of human remains like this one. A lot of the time, the police will know that someone is missing, and possibly come to harm, but they don't know where they are. And we have archaeologists, forensic archaeologists in our team as well. So we work very closely together with search operations for missing, possibly buried, possibly concealed individuals, sometimes buried in classic shallow grave. And often we find, dog walkers generally find bones, and those can be human remains that are on the surface, usually, you know, sort of away from the, you know, the main paths and things like that. Somebody has died in, either suspiciously or not, and you know, has been discovered of and has been there for quite a while. All the things that I showed you on that wheel about the identity we can hopefully help with from skeletalized remains, and certainly something that, as a more experienced anthropologist, a lot of my work now is things like alteration to bone, and the more difficult and altered remains like dismembered and burnt remains. Exhumations, we do get involved with once in a while. Sometimes there may be unidentified individuals that police will exhume to confirm an identity, or for other reasons, and mass fatality incidents. Forensic anthropologists have taken a more prominent role in mass fatality incidents, I'd say probably over the last 10 years, including Grenfell and you know, sort of humanitarian war crimes and things like that. We understand how the body develops, so if it doesn't develop as it should, we can certainly comment on that. That's sometimes where we get involved with abuse or neglect cases. And because of that development and age estimation techniques, we can sometimes look at imaging, CT and X-rays and make comment on ages of living. And certainly that's something that comes into immigrants into the country if we need to confirm their age. So it's a broad church. It takes in a huge amount of different case types. So that's forensic anthropology, but I know that you're interested in this particular case. So let's take it back to 2013. And we've already heard from Barbara about Christian and Robbie finding this skull lying on the bed of the River Coln. And police are called and the skull's recovered. And we have Ellie here who would probably be able to sort of give some context around, you know, how common that is. Finding bones is probably quite common, but human remains,
They're often not human.
often not human, yeah. And we at Cellmark and other, sound like the BBC, and other providers of forensic science are available, run a virtual email bones identification service. So you can email in bones, and most of the time, if they're sort of whole or decent amount, they can, you know, we can tell whether they're human just from a photograph. We don't need to call us out of the lab. So as we heard, Lisa Donnell came to have a look at the skull and gave preliminary opinion on it. And I'm pulling all this together because you've got Lisa, you've got myself, you know, you've got Victoria, who've all sort of, you know, sort of been involved with this. So we will come, and I have to say that, you know, there's quite a lot of concord from very early examination all the way through. So this is what the boys and the police were faced with, and I think somebody said in our conversations recently, it is, Victoria said, it's quite difficult to see. My pointer's working. So there's that, you can see the eyes. It's and this is the jawbone. So yeah, look, it's taken up the appearance of something that's on the bed of the river. So yeah, amazingly good spot, boys. That was quite, you know, quite a find. And as Barbara said, you know, absolutely right. You don't know from that, and I'll talk about that in a minute, about just what you can tell when you literally just have bone about the age. Well, you can't, so it has to be dealt with caution. So following that, I got a ring, I got a phone call, and as the police had to sort of rule it in or rule it out as being suspicious, and photos were sent to me and asked for advice on what we should do. So I think at this very early stage, just looking at the photographs from a forensic point of view, and that key thing is it of police interest? Well, it hasn't got any apparent soft tissue on it. So, okay, so we can sort of swing it away from really recent. the surface of the bone looked slightly eroded. So it's had some post-mortem effects of environment that have that have contributed to its appearance. I was sent a picture at the bottom right and had a look at the teeth. No apparent dental work, and that could mean that it's not modern. And if you, like me, and grew up in the 70s and 80s, they were putting fillings in as every couple of weeks. So absence, it is common to see dental work. The absence of it, of course, just might mean that somebody's looked after the teeth. So all the time you're sort of balancing whether we're swinging to modern or archaeological. But what was interesting at this early stage was that the first molar tooth was quite worn. It had all 3 molar teeth, so including wisdom teeth. But there was the first one that comes through at about 6 years old was very worn. Now, again, that can point to a more ancient population, just because of changes in diet, but throwing caution and not wanting to sort of make any judgments just on photographs. These are all the things that are sort of going through my head. Yes, it could be, but there might be other explanations. So what we always do in this case is recommend submission, because for a lot of this sort of opinion, you just need the bones in your hand. So that was what was recommended to the force. So that was what was going to happen. And then on the 16th of July, I get to notice that the rest of the skeleton has been found. And Lisa Donnell attends the scene and recovers a large proportion of the skeleton. Now, I know Lisa's online, and I know Barbara had sort of notes. I don't know if Lisa wants to come in or wants to make any comment, because I cannot comment on what was done at the scene. Maybe switch that in a second, but what Lisa did do, as I'm led to believe, was to look for a cut, and this is a very, very important thing to look for. And a cut is just as it says, it's where there's been activity to dig into the earth and remove earth, and usually, when you have certainly buried human remains, replaced. So that was part of the examination, as it would be had myself or one of our archaeologists gone out. Any comment from Lisa on that? Maybe. I don't know if we've got her on mic or crack on.
She is muted at the moment, but she can unmute herself if she has something to contribute.
She put up her hand if she has. Okay, so I was, so I received a further phone call. So now we have more bones and what to submit. So the first thing I'm foreseeing at this stage is this important thing about how old is it. And so I, at this point, took advice from our radiocarbon laboratory. We don't do this in-house at Cellmark, we subcontract it out to Scottish University's Environmental Research Centre up in Scotland, and they do radiocarbon dating for all manner of things. So everything from very ancient archaeological samples, tens of thousands of years old, all the way through to our forensic samples, and we have a specific arrangement with them. So they will be modern, and we'll talk about that in a moment. So I just queried whether the skull was still the best sample, and Professor Gordon Cook there said that possibly if we had more of the skeleton to go for the vertebra. And the reason for that is the running hypothesis at the moment is that the inner part of the bone, called the trabecular bone, turns over at a more rapid rate than other areas of bone. And the vertebra, these sort of spongy bodies that are shock absorbers in the spine, have a lot of this trabecular bone. So given that, and I'm liaising with the police, as an initial step, we agreed that only certain exhibits, as we call them now, have become police exhibits, were submitted. So, you know, this is the disclaimer. I only had the cranium, that's the skull without the lower jaw, and the lower jaw, and one vertebra into my lab. When we're instructed by the police, it comes in on a submission form, and they specifically ask us to do, to answer questions usually. I would love to sit and analyse a whole skeleton, but unfortunately I can't, because you know, we're funded by the police, who are funded by yourselves and the public purse. So there is a rationalisation to forensic examinations, you'll be pleased to hear. So we are led very much by what the police want to do. We will advise back and say, well, actually, we think maybe if we did this as well, or, you know, there's always a dialogue. But the predominant thing, obviously, was, and this is what came in on the submission form, we'd like to determine the age of the bones, i.e. the date of death or date of birth of the individual, to establish whether they're a concern to the police and require further lines of inquiry. We get a lot of these cases in, they're in every single week. So, you know, we've tailored an anthropology examination to record, because radiocarbon and DNA are destructive techniques, to record sufficiently should it go on to police investigation. But that is not the same as a full skeletal analysis. So yeah, we have this anthropology assessment to try and do that first thing, determine if it's archaeological or recent. And the way that there's quite a few criteria, and they're quite obvious. You know, is there any soft tissue? Is there any dental work, modern dental work? What's the feel of the skull? What's the weight of the skull? And things that have been in water are quite problematic, because they take up water and can be quite damp. So often we'll dry it out and see how it feels then. So you're looking for basically hints of residual soft tissue, whether they're grossly visible or down the microscope in the internal structure of the bone. And lots of things, you know, how much does it look like it's been affected by post-mortem environmental factors. So if there's any indication that it could be recent, then we would recommend it going for DNA for obvious reasons. And let's not forget that this is a continuum. So it isn't like, oh, there it is, that's recent, and that's, yeah, that's ancient. We can't pinpoint it by visual exam. But what we try and do is again, so do that swingometer, so it's more likely. But we don't want to miss getting a modern sample through DNA and checked against databases. So we would always recommend that if we think. We've just had a sample back this week on a skull that ticked quite a few recent boxes and went to radiocarbon dating and came back early 20th century. We think it's been in the sea. So where the remains have been, the environment they have been can impact massively on the appearance. And we all know about bog bodies and things like that. So it's not a precise science. We're just trying to you know, sort of push an indication of which we think it is. So if, you know, if it has these features that make us think it's lightweight, it's no greasiness to it, you will say, well, probably worth doing radiocarbon on this rather than DNA. And if we can't tell, this does happen, we'll have a discussion with the police and say, okay, well, we don't know, but what, you know, is there any factors around, you know, missing people in that area? Is it of interest? Let's send it for DNA or radiocarbon, but we'll take DNA sample and retain it at our lab. And we do all of our examinations in what are called DNA clean labs, so that, you know, incredibly thoroughly cleaned to minimize contamination. So that essentially is our basic exam that we do quite a lot. Why do we do radiocarbon when you've got a bones expert who's looking at it going, I think it's archaeological? Well, because radiocarbon is an absolute objective scientific technique. It's not an opinion, and it will put numbers on this, and, you know, it's tried and tested science. And we do get that, so, well, you're the expert. No, but because of all those post-mortem factors and the environment, we cannot be absolutely sure. Okay, so during that initial examination, what am I looking at? And this is our first proper look at our Fairford skull. Well, I'm noting the green discoloration. And there's actually, it's not very clear on this, but it's actually sort of moss and algae and like a frond-like. So that says to me that that hasn't been completely buried. Something's grown on it, and it's considering though I wasn't at the scene, it looks like, you know, aquatic vegetation. So that would suggest that that part of the skull has been above the ground level, the riverbed, for some time for that to grow. And sometimes you know you can tell the orientation that the skull has been in for some time by looking at things like that. I'm looking, even though I've not been formally commissioned to do an identification on this, but I'm starting to look at things that could indicate what the sex of this individual might be, the age of this individual. So I'm noting things like the wisdom teeth have erupted and look like they're what we call in occlusion, so they've started working together. And I'm also noting some unusual things that we'll talk about, that Victoria did a lot of work on, about, you know, what sort of population and biological ancestry might this person have. And there's some unusual things already that I'm seeing about this. It's called prognathism. There's this jaw that's upper jaw that's jutting out. The shape of the nose is quite wide across the bridge of the nose, and the shape of the nose. The nose is quite you know, sort of diverse area of the face. So the shape of what I call the nasal bones that make up the bridge of the nose, the width between the orbits, the eye sockets, what the bottom of this nose nasal aperture looks like, the width against the height, and things like that. And one thing that was immediately quite odd is this quite protruding forehead. But eyes on the prize here for the police. That is pretty much as far as I took it, because let's not forget, Professor Cook had said send a vertebra. The skull was going to remain untouched. So that's sort of where I had to leave it. And it is difficult. I've got a case at the moment, which is also incredibly unusual. And you're just fascinated because of, you know, this is in this case, a modern unidentified individual. So, you know, we were talking just before about, we look at skulls and imagine what the face is like. So the other thing that I looked at was the vertebra that they'd sent in for, that was going to go for radiocarbon dating. And as I'll talk about in a little more detail, one of the very first things that I noticed was the fact that, can you see this little gap here at the top and the bottom? Is like a sort of gappy line. It's a bit of a close up here, and also here. This is an indication that the vertebra is still growing or has recently finished growing, and is now sort of fusing all together and becoming one solid bone. Bones grow not as a single unit, but in a number of different parts as growth happens, and then they ossify and come together. So studies have been done on skeletal populations where they have known age at death. So you make these observations, you go to the literature, and you can get age ranges. Now, one of the biggest problems in osteology, biological anthropology, forensic anthropology, is if you think of the immense variation across the world and the immense variation that will be in those skeletons, we're using methods that were devised on one population of at best usually a few hundred skeletons. So the methods that we use, it's very important to look at the population that it was based on, because it will predict the age of individuals in that population. And this is one of the fundamental issues of osteology. So you have to be aware of that. But a lot of time, that's all we have to go on. So with that in mind, especially as a forensic anthropologist, a lot of this stuff is done on modern populations. So we, just from this, we were looking at age ranges of a teenage into early 20s. And studies have been done on those wisdom teeth as well, that puts us sort of in that similar age bracket of late teens and early 20s. So I would say that, we know we've got a young adult just from looking at one bone. The skull, we look at, how robust it is, basically. And I'll come on to that in a little more detail. So at this early stage, Lisa and now myself are saying that we think it is possible female, young adults. We can put some numbers on that. And this biological ancestry is looking interesting. There's some odd things here. So I did actually dig out what I said, and I never said it was definitely a certain ancestry. Because as we'll go on to, there's a whole bit of work to do with that. But there are some traits that could suggest that this has some contribution from sub-Saharan Africa. Okay, so we send it up for radiocarbon dating to Scotland. What is really interesting about radiocarbon dating in a forensic context is that there is a really, really clear demarcation in radiocarbon between recent, modern, usually of police interest, and older. And that comes down to the fact that radiocarbon, the radioactive isotope of carbon, is in the atmosphere. It's combines with oxygen, becomes CO2, gets incorporated into the carbon cycle. And radioactive carbon fluctuates throughout time. Then what happens in the 1950s is nuclear testing, and huge amounts of radioactive carbon are pumped into the atmosphere. And this is the levels of radiocarbon. So they double, basically. You can see it's 100% all the way up. So they double within what is less than 10 years. Woof, they go up. That goes into CO2, goes into the carbon cycle. For all those people who were alive in the 1950s, 60s, it was in the food, and it gets into your tissues. So obviously not critical levels to cause particular harm, unless you're literally living near the testing, but it is dramatic. So if bone is analysed and has these heightened levels of radiocarbon, we know that it has to be, that person was living, breathing after 1955, certainly, and usually, we can usually sort of say about 1950. So for police, that tends to be really useful. 1963, there's a testing ban, and the radioactive carbon drops away again. It is just, I was told by an expert a couple of weeks ago, it is just now getting back to pre-testing levels. But you've got this nice curve. So if you take a reading of radiocarbon within your tissues, you can plot it against this curve and work out when that was, that the levels were so. Takes a very small amount of bone. They extract the collagen from the bone, and I'm talking on behalf of our radiocarbon experts here. I'm not an expert in this. And then they put it through mass spectrometer and to look at the ratios of the isotopes. I'll leave that over one side because the test results came back for the Fairford skeleton. We're not in nuclear. It's definitely pre-nuclear. It hasn't got these heightened radiocarbon levels. So we're looking at the general fluctuations through time. And it's atmospheric carbon, and obviously databases exist. So our experts calibrated that this person died between 896 and 1025 AD. That's a high level of confidence. Interestingly enough, in the industrial period, when the opposite happened, i.e. loads of stable isotope, stable carbon was emitted in the industrial era through factories, etc., this skews everything a little, it upsets the natural balance, as we now very well know. So it is a little more difficult to pinpoint dates within the industrial period, so late 18th century to early 20th century. Just as an aside, back onto that nuclear thing, I just thought I'd put in this modern forensic case, which demonstrates, I think, really nicely how useful this can be in a case of unidentified remains. And this is a case that I worked on in 2010. These are all media images, but this work has been published by myself and Professor Cook. So all this is in the public domain. And this is a site in the centre of Manchester where they were building the new co-op headquarters. Massive building now. So they were clearing the land and they found a number of bones. Police were called, scene established, archaeological and anthropological examination. I could do a whole lecture on this, but I'll also skip to the radiocarbon point. A number of items were found with the body. It'd been disrupted because of this clearance, so there wasn't a neat scene, if you like. But certain items of clothing were found with the body, and lots of work was done by the police to try and trace and age this. It was associated, that's the word I used, it could have been wrapped in a carpet. That carpet fitted a Ford Cortina. That's the amount of work that was done to track down the vehicle that those bits of carpet fitted. And a facial reconstruction was done. This case was on Crime Watch, sort of probably 2011, 2012. And this case remains unsolved today. So this lady was came to a violent end. We can't prove murder, but had injuries that were significant. And all this work was done. But because this was a disrupted site, and because that site had remained unaltered since the early 1960s, when this happened, when this person was alive and when the death might have occurred, became really critical. And radiocarbon came in really useful, because what we did was to look at the radiocarbon in teeth. Now, radiocarbon in teeth gets laid down and doesn't change. Your bones are adapting and altering, but radiocarbon in teeth, or the carbon in teeth, stays the same. So it's a snapshot. So we looked at the radiocarbon in a number of teeth, early forming teeth, incisors, and your last tooth, which was the third molar. And we plotted it against that bond curve, and it was bang in the most active area. So we could get quite close readings and narrowed timeframes on it. Now, there's variation with the rates that teeth develop. So that's where the variation in that top table comes in. But I'll summarize and say that our expert would say that the date of birth, if you track back from when you know that tooth develops to birth, was between 1950 and 1954. And on the right, you can see date of death from the bones, which was coming in at between 1969 and 1974. So that skeleton had been there for 30, 40 years. And it fitted with the Anthropology, because do you remember those vertebrae with the little rings? And this skeleton had them as well. So again, this person was within that sort of 18, early 20s. So we've got a date of birth, date of death that fits with what we're seeing on the skeleton. I love this. It's just really nice, neat science, and it puts it in time. It's a difficult time period to investigate, obviously, in 2010, which is the predominating reason why I think this is unsolved. But obviously we now know where we are in time. So this is where I will formally introduce Victoria Halbridge. As I said, you know, when we got that radiocarbon date, understandably, the police are like, well, it's not a police case. So that is where my part stopped. But Victoria picked this up for her master's dissertation in 2015. Now, I wasn't sure if Victoria was going to be here or if she's going to speak. So from this point on, everything that Victoria's done is in blue. Just so you know, it's not me. And I won't put her on the spot because, you know, it's now coming on a few years, but I'm sure that she can add to what I'm about to say. But I'll go through some principles. We've talked about this a little, but when we have a large amount of the skeleton, under this identification, we'll look at estimation of sex. One of the most important bones or group of bones is the pelvis, which you can see in the photographs. Understandably, this is because of adaptations of females for reproduction. So we know it, don't we? Wider flaring pelvic bones, what's called the pelvic inlet is wider. The sacrum, that triangular bone, the base of the spine, doesn't curl in as much as it does in males. And there's a list of things that we will go through and observations that we'll make. One of the top of the list usually is what's called a sciatic notch. So you're at the back of the pelvis, and because of this expansion, this sciatic notch, this is much wider angle in females. So there's the pelvis is one of the more is the reliable thing. So when we're talking about just a skull, I personally would never confidently attribute a sex to a whole skeleton. Certainly, you know, directing police to look at their missing persons list, I will caveat it with the fact that if we can combine it with the pelvis, it'll be much better. So this is one of the key areas. Also, generally, just because of generally males being more robust, we'll look at things like the size of the heads of the arms and the legs, the joint surfaces. So we do look at the skull, as I said before, it's generally more robust. This is massively caveated with the fact it depends which population you're in. You know, you can have what we call gracile males in certain populations. But we look at certain areas like above the eyes, I can do it on here, it's amazing. So the protrusion above the orbits, called the supraorbital area, and the glabella, which is the central bit. So is it protruding? Muscle attachments generally a little bigger in males. So this mastoid process at the back, where one of the big muscles of the neck's attached, and where muscles attach at the back. So those are three. There's a longer list, but just so that you get an idea. So you can start to tell differences between males and females. So this is Victoria's work. Having been able to look at everything.
So she just said I haven't done this for 7 years, and I recently reread my dissertation in incomplete embarrassment. So bear with me. So my research project was based on the initial findings from Linda and Lisa, and essentially, just to give you a bit of background, I went to Bournemouth University and we studied forensic osteology. And when we had to choose our dissertations, everybody had their different subject, and the skull came up, and my lecturer said, someone's got to do this. I was like, okay, so we did that. And essentially the purpose of this was to understand, first of all, confirm or deny everything that the forensic anthropologist that originally looked at it had, the work that they'd done on that, but also to look mainly at the ancestry, because even though it was reported that it's kind of ambiguous or different to find a skull of African ancestry in the UK at that time, which is about 1,000 years ago. So anyway, first of all, we started with the estimation of sex. I did the skull morphological analysis and also the analysis of the pelvis, both of which came up completely bang on right female. And then we did the stature, which was just taking measurements of the long bones. And this is my results, as you can see.
Stay there.
Yeah.
There's more. Yeah, I must say that Victoria hasn't seen this presentation, so yeah, we're winging it. Okay, so just a little more detail and just some pictures on this estimation of age. You know, that right from when bones develop, about 8 to 10 weeks in utero, you can start to age individuals by bones. But I'm jumping through development to the area of interest, which is young adults. So the sort of things that you know we would be looking at is the fact that the bones, some of the bones, this is the pelvis that we've been talking about, actually grows in 3 parts and then comes together and fuses into one. So has it done that? Is what we call secondary epiphyses. You can just see it here, this little, similar to the vertebrate, this little sort of sliver of bone here. You know, is it there? Is it attached? There's our vertebra. This is I think that actually might be the Manchester case, strikingly similar. These are long bones and how they grow. So as I said, in a shaft with ends, these sometimes called growth plates, we call them epiphyses. They develop and then eventually fuse to the bone. You can see this on X-rays as well. This is a very old case, one of my first cases. Again, very similar age. This is the wisdom tooth, the 3rd molar. So even if you can see it above the jaw, what's going on underneath, and have the roots developed, because these roots are blunted, not pointed, so they're still developing. So lots of indicators. This is a really childhood and this age, we can be relatively accurate because of all these many changes. So we can narrow it down to usually, you know, sort of 3, 4, 5 years, taking into account. I have Roger Miller requesting remote control. I'm going to decline, if that's okay. Yes. Okay, so as we move past that development, when everything sort of stopped growing, we then go into degeneration. I think we all know that, but you see it on the bones as well. And this has been researched and tested, and these strange things here are the joints, surfaces at the front of the pelvis. You remember it came together at the front, right? You know, right at the front of the pelvis. If you open those up, it's called the pubic symphysis. And this changes if you look at directly underneath those stages. It changes, fills in, and then eventually sort of gets very gnarly. So we would look at that and you know, assess where what the appearance was against these known stages. The middle picture is the other joint in the pelvis, which is the back that goes to the sacrum, that triangular bone. And again, this can change. And the strange picture on the right is what are called sternal ends of ribs. So it's where the ends of the ribs that are at the front, where they meet cartilage, when it comes to your breastbone. And again, they change, and they change in appearance, and that's been researched and tested. So we put them against these standards. So there's lots of methods, some more accurate than others, that we can estimate age. And I know one thing that Victoria did on this case was this tooth wear on the molars. So again, standards about how much has it worn down, and other techniques not within this case, that we can go microscopic. The bottom is another sort of tooth wear method. In the center, that's under the microscope bone structure. Because bone's turning over, you can look at how the microstructure changes. And on the right hand side is osteoarthritis. So it's sort of bony growths on the spine that tend to come with age. But you can imagine activity impacts on this quite a lot. So it's it's not as reliable as some others, because it can be variable on what on the activity of the person. So this is Victoria's age work.
Yeah, so very similar to what we already went through. So yeah, as you said, we use the pelvis, the vertebrae, the long bones, and the tooth eruption and wear. You're right, I did discuss the tooth eruption slightly, and I know you said that the first molar was slightly more worn than the second and third, meaning that they probably had quite a hard diet when they were quite young. The reason that you don't see the kind of wear that you see on archaeological skeletons nowadays is because we have such a soft diet, mainly because of the invention of mills, which grind down grains for bread. So yes, absolutely. The conclusions that we came up with was that it was an adolescent or early adult, probably between the ages of 17 and 25.
Yeah, that was done specifically on the teeth because they were, can be more accurate than, the skeleton can be more affected by, nutrition and various things. So I think the 16 to 20-year-old was looking at everything together as the most likely, and we often will give a very wide range and then a narrow range. So we know where we are. Okay, so this was the particular interest of was this a native Briton? And just to put into context, a term that's coming out literally in the last few years that's been is population affinity. Historically, it's been called Ancestry, but actually what we're doing, and Victoria, I'm sure this is the mainstay of a dissertation we'll talk about, is that we're looking at that skull and trying to fit it to known populations by looking at features on the skull and also measurements. So what we'll do is there's two ways of doing it. As I say, you can go through this list and say, has it got a nasal shape like this? Has it got these features? And you can score them. Historically, it's been usually put into three groups. Some very old archaic anthropological terms like Caucasoid, but now the general accepted term is white, which is to Western European, Sub-Saharan African, and East Asian. These are very broad groups. Ancestry is a contentious issue with forensic anthropology. It has been since its inception. I'm not saying it's an imprecise science, but again, go back to that variation. So to be able to put this huge variation into groups is a very problematic exercise, especially in times where there's been migration and things like that. So recent research has said that increasing the number of groups is more useful. A lot of this work was done in the USA, so they're introducing groups like Native Americans and Hispanics, which aren't relevant. So we could talk about the politics of ancestry a lot, but I think we'll just focus on what it means for this case. So this list is just talking about after you've done the trait list is actually taking a large number of measurements. It looks like lots of crania, but let's throw it against the billions in the world. And these are databases that you plug your measurements into. One's called Cranid and one's called Fordis. They do essentially the same thing. They have slightly different makeups of cases within them. You have to talk about the problems with these methods.
Yeah, sure. Okay, so both of these are statistical analysis programs. You take measurements of the skull. It's really simple. You take measurements of the skull and then you put them in the program, and then it spits out a result. So limitations with these kind of things. You just said there's 3,000 crania used in Cranid. That's a very, very, very small sample. That's 74 different populations across the world, which maths is hard for me, but I don't know how many that is on average, but it's very small. It's way too small to be able to come up with any kind of reliable statistics or conclusions. Fordisc, pretty much the same. I spent most of my time on Cranid on this because Fordisc had a smaller population, a smaller database, and kind of a different population, but it's different. Limitations. They're also limited by where they are taken from in the world. So the skull that I worked on was vastly out of the ranges, we'll get to this probably, was vastly out of the ranges of what kind of naturalists could come up with. And one of that could obviously be, well, there's multiple reasons why that could be. Obviously, any pathology, the skull was very strange looking, you've seen it. Pathology could have played a part. It could be of mixed ancestry, but also the database just could be wrong or missing a slice of a very, very big pie. Who are my main?
It's true, yeah, it is trying to, it's square peg round hole sometimes, because if your population, if you know, the problem we're dealing with unidentified remains is you're starting from no information, so you're trying to put it into a population that exists. Now, a lot of this is distance measurement, so how similar is it? And what Victoria found is it just wasn't coming up as similar to anything really in the database, right? So the reasons for that are, you know, and I think you got this from, you know, the creator kind of, have you done it right? And I've read Victoria's dissertation, it was incredibly rigorous, measurements taken 3 times, you know, tested on a test crania, you know, so that I think that, you know, the chances of that are incredibly small. What's more likely is that it's just not, that what it is similar to just isn't in the database. And I think you sort of discussing whether it could be because it's actually mixed ancestry. So, you know, they're taking sort of what they're expecting to be, you know, sort of typical skulls, or, you know, sort of from those populations. But as soon as you know, you start sort of mixing them, then they become untypical. So I think that's one explanation. And, you know, and the other one is that, yes, there is a population out there that at that time, if you'd sample that, it would go, boom, that's where it is. Don't talk about the Africanness of it or not.
Yeah. Do you have a picture of it?
I think. Have I got one coming up? No. Go back. I'll just remember where we are. I think the initial ones are probably the best. Yeah. Here it comes. There you go.
Okay, so I can't speak for you, but what I think is the initial, Linda, you came up with the fact that it could potentially, possibly, maybe be of African origin, or at least not of Caucasian origin, which is what we would expect to find in Roman Britain at the time. So the first reason that I think you thought this is because the nasal aperture, which is obviously the nose hole, is a lot wider than we would expect to see in Caucasian populations. So in a Caucasian skull, the nasal aperture will be a lot thinner and a lot taller. And in an African population, the nasal aperture is a lot wider and a lot shorter. And the reason for this is because of where we are in the world. So African skulls, or African people, they live down in very, very hot climates. And they have very little need for the air that comes into their bodies to be warmed or humidified, which means that the nose doesn't have to have an adaptation that warms the air. With Caucasoid or Caucasian skulls, we need a bit more space there to heat the air that comes into our bodies, and also to humidify that. So the nasal channel is longer. So that's why you would see that morphology in skulls like this. And I don't have a reason for this. The prognathus that you prognathism that you mentioned earlier, that's the jutting out of the bottom jaw. And you find that a lot in Black populations. You don't tend to find that in Caucasian populations or East Asian populations at all. Is there a reason for that?
Not off the top of my head. I'm sure there is.
Also, this this portion of the skull here, where the nasal bone sits, that is a lot wider than we would expect to see in Caucasian populations.
Things like, yeah, like sutures, you know, the joints of the skull just have a slightly different formation. So yeah, I mean, there were definite features there. I can skip, bear with us a second. Okay, so hopefully now you can understand why, you know, Victoria and I completely agree. You say that, you know, sort of negative British ancestry was unlikely. And what was, you know, we don't have an answer, but what the possible, you know, sort of possible explanations for that might be. So going into more isotope science, and I thought this was a brilliant thing to do in an osteology dissertation, because certainly part of you know, the exciting thing about osteology is dealing with all these other disciplines that can bring something to the party as far as information is concerned. So we talked about radioactive isotopes, stable isotopes, the ones that don't degrade, can be looked at to try and work out where that person lived, drank, took in their food. And one that's looked at is strontium, and that comes from the geology, the underlying bedrock. And of course, certainly in archaeological populations, source water would have filtered through bedrock. So this was outsourced to a lady, Janet Montgomery, and I've approached her on forensic cases. And she looked at the enamel from the lower jaws, and a similar principle to the radiocarbon, an early one and a late one. You know, how is this changing? Is the diet changing? Or, you know, the source of these isotopes changing through early life? And what was, and I don't know about you, but I don't profess to know about the pure science of this. But there are databases, and the readings of the strontium isotopes came back as actually similar to the strontium isotope signatures around Fairford. So we have this foreign-looking skull, but the inference is that this person was drinking water and food sourced in the local area. So that puts this person living there for the early part of the life, if not all the life. Go on, you do this one.
Yeah. Also, with regards to the which teeth we looked at, it was I think it was lower, this one, the left one and the left three. So first and third molars. The reason we looked at that is because, as you said, we wanted to get a kind of good snapshot in time. So the first molars come through at about 6 years old, and then the third molars come through in your late teens or early teens. And that gives us a nice kind of snapshot. So when the you understand this well, when the first molar enamel was being created, we can kind of infer that that person was there from a very early age, but we can't say for sure that they were there from birth. Anyway, so the teeth also showed periods of stress. So this is called hypoplasia, where the teeth show ridges along the enamel surface. And this shows periods of stress or kind of nutritional deficiency in early childhood. So it's where that enamel stops producing for a while that teeth is still growing, and you see those little ridges on the teeth.
You'll never look at teeth the same, will you? No.
And as far as I could see, with my limited experience, there was no indication of cause of death.
Of course, we've got doctors in the audience. How many diseases don't impact on bone? There are many, 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 many. And of course, that's always the missing link, and that's the missing link in forensic casework. And I write it in pretty much all traumatic injury statements. Of course, there may be injuries that are impacting on the soft tissue and not on the bone. But I think we can say nothing gross that, pathological or traumatic that explains what is even in these times, a premature death. So back to how this person got there. And I would be really interested in what Lisa can tell in this ridiculous environment of sloshing around in a river picking up bones, as to whether there was anything interpretable about the body position at all, because that's what I would be looking for and osteoarchaeologists are looking for. And to look at the surrounding archaeology, the impact of natural processes like soil deposition, but also man-made processes like digging graves and things. So I think because of the peculiarity of this being in a river, when it's found, that understandably was information that we just couldn't get. And of course, we know that rivers erode. So I would say I'm not an expert on this, but there's a very high chance that the course of the river was different back in the sort of the 9th, 10th, 11th century. So this could very well have just been open ground, probably quite a bit higher, and the river over time has eroded and eroded the bank, and it's just in 2013 that these remains, it's got to reach these remains, and they come out. This is definitely, I'll put them all up, though. It's what we were talking about this there's a feeling about this. It's become an African individual. Hopefully we put some context around that. We're not saying that definitely, but this person with some probable African heritage, I think we can say. It's not, there's a feeling that this was unusual at this period of time, and you did research on that as well, didn't you?
There's absolutely no evidence to suggest that during the Roman period and beyond, there was a population of exclusively Caucasian British people. In fact, back in the times of the Romans, and we have found remains and skeletons of people that are very, very high status that have been identified as having African ancestry. There was, it was a very kind of melting pot type society. It seems to have changed around the time of Elizabeth I's reign, where she took exception to people of different colours and races in the country. And from then it just kind of seems to have trailed off, and it might have had that effect around that time.
It's a complex issue, isn't it?
Yeah.
And still is today. Yeah, it just feels like the Romans were very liberal about a lot of these things, and if there's any historians who can add into that, that'd be fascinating as well. And of course we can throw Vikings into the mix. Now they didn't come from Africa, but were well traveled, and we've got a Roman Empire, we've got Viking invasions and movement. There cannot not have been massive movements of people, whether willingly or not. So gosh, we could talk about this for hours and hours, and it's been quite hard to squeeze all of this to give you a good feel of the work that Victoria's done and that we do generally with police cases into a fairly short space of time. Hopefully that it's given you a good rounded view of what we look at. Further work that could be done, talking science for a minute. No DNA has been done on this skeleton. It would be ancient DNA techniques, which is quite specialised, but there are DNA techniques where you can look at biological ancestry and populations, and Victoria brought this up as what would be very, very interesting, is to actually see the face of this lady. Obviously, this comes down to the age-old of support and funding, but certainly the facial reconstruction artist that we work with on the Manchester case does a lot of facial reconstruction of historical figures. So, that would be interesting as well. So the story may not end here. And there's lots of bits that are still gaps, but hopefully there's quite a lot that we have filled in. So the last bit I just wanted to get straight, because in 2013, this picture appeared in the media. Is this from?
I do that picture. I laid those bones out. It's all me.
There's a straight cough, and quite understandably, you know, that, my goodness, you know, that's, you've got everything in the right place, you know. But because of the involvement of a forensic anthropologist, things came out in the media, which was, this is an archaeological online forum. Yeah, I took a knocking over this, not personally. And yeah, apparently I was wearing dark glasses and a hat and scooting out of the door by not wanting to give comment. But thank you, Ellie, for, you know, for that. Obviously, you know, that's you know, if we'd done a full analysis, then, you know, we obviously would do pictures that Victoria did. So yeah, this is, you know, this was just a little niggle, but you know, hey, we did our work, didn't we? So and I think generally, you know, even up to quite recently, there's a misconception that I did a full anthropology examination. That's what a full anthropology examination looks like. But hopefully you understand why I didn't, and the fact that a lot of work has been done. So thank you ever so much. Any questions? Oh my goodness, there's one.
They rather glossed over the bossing of the frontal.
Ah, yes. Yes, no, we did. Actually, I was running out of slide time. I thought, shall I do a whole section on pathology? And I was like, oh.
If it is an eagle, an African skull, one of the features of sickle cell anemia is bossing of the frontal bone.
Did you come up with that? Thalassemia.
Okay, that's really interesting that you say that.
Sickle cell anemia.
Sickle cell anemia.
Yeah.
Thalassemia is there are still some cases of thalassemia apparently in the Forest of Dean, interestingly, from Roman times.
Right.
But sickle cell, because thalassemia means disease of the sea, it's essentially a Mediterranean disease.
Yeah.
Whereas sickle cell anemia is another hemoglobinopathy, but is more attributed to African folk.
Yeah. Yeah.
So I just wondered whether, again, cause of death, possibly, young
It's-
cause of death, sickle cell anemia.
It's so interesting that you say that. It's in my mad rush to reread my dissertation and reteach myself forensic osteology. I decided to go back and look at what kind of pathology would cause this frontal bossing, and sickle cell anemia was one that I found this morning. I have multiple tabs open on my phone. From one of my, yeah, exactly. I would love for it to be done.
DNA analysis would show.
What would be this, because you touched on this, what would be the survivability with that disease?
Oh, in those days, not.
And I think you made that point, is that the likelihood of surviving to 1820.
Consistent with somebody dying late teens.
Right.
20s. Yes.
Gosh.
But the DNA analysis, unfortunately, would show whether it was sickle cell, whether they had sickle cell anemia or not. It's a
Yeah.
transposition of one amino acid on the global molecule.
I think we, yeah, I mean, I obviously didn't spend a lot of time on it, but it's massively noticeable, you know, I've known, and it threw everything out of kilter with
Yeah.
all the crania in the databases. You know,
The
it was a,
statistical analysis, the measurements between here and here, here and here, and just down here as well. There and there, just they were off the charts. They just didn't have a
So you don't think
skull that
it's
was
an
like
artifact?
that.
well, you looked at it a little closer. There was, I mean, we're used to looking at porotic bone, you know, and sclerotic bone and bone apposition and things like that, and it didn't seem to fit with any of those classic sort of, you know, sort of changes.
I'm not sure what the morphology is. Confronting Boston.
Yeah. So Barbara,
Very quick, this question actually isn't you, Linda, it's to the audience and the audience online. This is absolutely fascinating. I really feel that there is part 3 to be done. The cost of DNA nowadays, I know it's specialised to actually get the DNA from the bones, but it isn't that expensive. is this an opportunity? Caroline Morris is in the front. Is this a crowdsourcing opportunity with Cirencester and Fairford to find out these?
That's put you on the spot, isn't it?
What sort of money is involved?
To be honest, I have no idea. I'm a 19th century historian. But I mean, it's always going to be a money thing. So, but I mean, if anyone had a project put together, the museum, I would imagine, would support it, because it'd be interesting to find that out. But
I would see the museum being the place that organises the crowdsourcing, with help obviously from myself and others. But do the people in this room feel that they would contribute a little just to find the end? What the DNA would tell us? It'd be amazing. And I don't know the cost of reconstruction, which I imagine it would be quite expensive.
Depends what you mean by expensive, you know.
It'd be lovely to have it in the museum and actually see it. I believe she got a nickname, is that right, Kelly? Matilda. It'd be nice to see Matilda.
I mean, I know Professor Caroline Wilkinson. She's at a place called Face Lab. Google it, Face Lab at Liverpool John Moores. You know, she's known as 20 odd years, and you know, I'm actually just had her team in for a current case. So I have got costs, but they might be different for a, you know, research historic you know, sort of case such as this. So you know, I could certainly pass on her details so that you could at least scope that out and see what it looks like.
When I was talking to people there, so many people can't be here tonight. Everybody's interested in what's going on, and but all of us have heard what they said. Absolutely fascinating. You know, well done, the boys for find everything else.
I've not said this, and this is testament to Lisa. You know, remarkable recovery percentage. You know, we don't get that in forensic cases of stuff that's, you know, just on the ground after a couple of years. You know, inference is that it's sort of been sealed within the riverbed, and you know, and obviously I assume some excavation, you know, that's just uncovered it all you know, together. So, you know, I'm sure they'll attest to this. It's a fantastically preserved skeleton for the age, and so, you know, I sort of rack my head what else you can do with it. I'm sure there's you know, there's potentially more, because you've got pretty much everything there. But the facial reconstruction is doable. You know, with the support and funding, you could do that tomorrow. You know, that's a doable. The DNA, I have to say, when my company are a DNA company, and they have specific techniques, obviously mainly dealing with modern cases. We do the MOD's World War I skeletons and identification, so I know we can go back that far. We have done various project work on older stuff, but it's not something that we specialize in. But there are ancient DNA specialists out there, and presumably pathological DNA specialists and things like that. So I think that there's certain certain specialists within the country that could at least start, you know, sort of telling you what's possible.
I think the Science Society would be interested in finding and making this go further. So we might be able to coordinate or at least contribute to that.
Well,
I think you can have the historic.
feel like you're telling me. I'm like, wow, that's well, yeah. I mean, it is you know, there's so much there that, you know, there is still more potential, as you say. So I will help where I can. I'm a little outside of historical investigation, but I certainly know there's Matthew Collins at the University of York is one of the most eminent ancient DNA, and he does a lot of protein work and things like that. So that would be my starting point to ask advice. There might be other people who can contribute. So there'll be other people who can input into this.
I'd just like to comment that I have actually heard from Bournemouth University that there is someone there who'd quite like, who wants to do some work a little like you did at the time, who'd quite like permission to scan and stuff. So I think she's an enigma, but I think she's still generating a lot of interest.
Yeah.
So I'm fairly sure Bournemouth would still be interested in you know,
Doing some
pursuing
further
more
work,
developments, yeah.
I have 3 questions from Zoom, 3 comments, I suppose. Firstly, James Thompson says, great presentation. Were heavy metals measured in the bone or tooth enamel? And I presume not. Not yet.
Not yet,
Not yet.
no.
Okay.
Where there's isotopes, there's lots of them.
Yes, yes. Christian, Marie, and Steve ask, when is the skeleton going to be on display? Oh, it's on display.
It's not, it's in the museum stores with hundreds of other examples of human remains. So it's about money and it's about honesty and it's yeah.
Okay.
I'm slightly above my paper.
And thank you. Simon Henderson says, I'd help on a crowdfunding project to find out more. It would be great to see the face.
Well, let's scope that out, and so I can certainly do initial contact with that and see what that looks like.
Oh, Simon Henderson asks, which museum? I presume that's the Cirencester Museum.
Yeah.
What I'd also say about Caroline and her team is they do faces, they do skulls, you know, much more than I do. So, you know, they look at a lot of skulls. So, you know, I think hopefully Victor would agree that you know, somebody who specialises in that might add something more to what we've already said, and you know, and may be able to link it with pathology that they've seen before, or you know, ethnic groups. Again, I had them in for a case, and they're thinking the same, but with a lot more of a database behind them. So that's certainly an easy conversation to start with Caroline and her team. Thanks ever so much for your attention. We have run over if there was a time, but hopefully it's been of interest, and it's lovely to talk about something that, no disrespect, not a criminal case, and to really immerse ourselves in you know, in the real detail of skeletons. So thanks very much.